Monday, the 18th of September. It's probably a few minutes after 8 o'clock. What we have here is tonight I plan on setting the parameters up so we get a 6-inch view of a number of select deep sky studies so that we can get a sense of how someone with a 6-inch telescope, 75x, which means basically 2 millimeters of exit pupil. Basically you divide the aperture diameter in millimeters by the power, 75 power into 150 millimeter scope is 2, and 2 millimeters is the size of the exit pupil of this field of view in the eyeball. So let's just, that's kind of technical, but that's okay. 2 millimeters exit pupil. One more example. 2 millimeters of exit pupil on a 200 millimeter scope. What would that be? Aha, if you thought to yourself 100, you'd have gotten it right. All right, so what we're going to do is we're going to explore this particular study a little bit because it's overhead. It's in the darkest part of the sky. There are some high, thin clouds, no guarantees. And I'm thinking I'm going to put this video up, well, proverbial hell or high water anyway, because I've been out last several nights, high, thin clouds rolled in, they got pretty bad, and I bailed. So here we go. 2 flood is what I consider basically a 50 millimeter telescope view of the sky. That's 2 inches in aperture diameter. 150 is not the way I want to go. I don't want to go that way either. Buttons, buttons, who's got the buttons? Alright, so here once again is 2 flood, 50 millimeter, 4 flood. Now notice the AGC max is staying the same. We're starting to see a few more stars. So I guess that's probably going to be somewhere around a 3-inch view at this time of the evening. Now we're going to go to 8. Now suddenly I'm beginning to see a ring-like apparition near the middle of the screen in the high contrast region. Aha, we wonder what that might be. Okay, so at this point we can see, I can see the ring itself. I'm hoping the camera picks it up too, but there is nothing else to be seen. So let's go to 16 flood. All right, now 16 flood. Now the very interesting thing that happens here is we're beginning to see texture in the ring, but most importantly, do you see this faint little star at the tip of my finger? That star is known to be magnitude 13. So what it does is, because I have traditionally I've used a 6-inch scope in the past to observe the ring in other studies, I have noticed that that star begins to pop out at about 6 inches in aperture, which has about a 13 to a 13.5 magnitude reach. Now, so I am basically at this point verifying that shutter speed of 16 flood and a sensitivity of 36 decibels roughly gives us the views of a 6-inch telescope. And for the rest of the evening, we are going to stay with these settings. Our next study on the 6-inch aperture parade is a globular cluster. The designation is one less than the ring. This is Messier 56. I can give you some data on it, but basically I have noted that Messier 56 in a 6-inch scope shows you a faint, hazy region with maybe a half dozen faint stars resolvable. One thing I am not seeing here is any core in this image, but I am seeing resolved stars, and I'm hoping you're seeing it too. So Messier 56 and Messier 57 both tend to agree that the settings of 16 flood at 36 decibels of auto gain control gives you the rough equivalent of a 6-inch aperture view of the heavens. And we have another dozen or so to see tonight before I'll be done with this 6-inch tour. What you're seeing here is Messier 22. It is showing some brightening at the core. However, unlike Messier 16, which is probably an 8.5 magnitude galaxy, this one, cluster, globular cluster, this one is probably somewhere around 5.2 to 5.3, probably the brightest cumulative magnitude globular cluster visible from the northern hemisphere. However, it's got a problem. It's pretty far south. However, if you were out with a 2-inch telescope and this globular cluster was in the middle third of the sky, you would be able to resolve its stars because its brightest stars are of about the 11th magnitude. So there is a good instance of a study, Messier 22 globular cluster in Sagittarius, that somebody, even with a small scope, now you'd have to push the magnification up to resolve stars. 1 millimeter exit pupil on a 50 millimeter aperture scope is how much magnification? Alright, so we're going to go on to Messier 22 now, which is more for a 4-inch scope. Okay, I did misspeak. It's Messier 28. Messier 28 should give a good view from a 4-inch scope. It's the minimum aperture scope that would show you a nebulous realm in the sky plus a few resolved stars in the perimeter. Messier 28. I'll give you a little bit of data on it. Now remember, now that we're operating at this lower flood, it doesn't take the scope very long at all to compile an image. I was kind of getting a sense it takes about 4 seconds of 6 passes, about a half of a second for 6 passes, roughly 3 seconds to fully compile the image. That's one of the beauties now of using these lower settings. Stars look more like stars and images compile much more quickly. Let me give you some data on Messier 28 so you can understand why it might require a 4-inch or 100 millimeter scope. It's a globular cluster in Sagittarius, magnitude 6.9. Now remember, Messier 56, which I didn't give you data on, is about magnitude 8.2. This cluster is about 15 arc minutes in size, which is about twice the size of Messier 56, 18,300 light years distant, but unlike 56, it's at minus almost 25 degrees, and yet I think we're getting a pretty good view. We have more. Here we see the Lagoon Nebula, Messier 8. This is how it might look in a 4-inch refractor telescope, and that was the same aperture required with Messier 28. Now I'm getting all these values based on average surface brightness using a calculating software program I wrote some 20 plus years ago. This data is published in a thing called the Astronaut Geekjoy Deep Sky Atlas, which also was published a couple of decades back, and that's what I'm basically using for reference to both identify and determine the minimum or optimal aperture scope that can see and reveal something of the basic nature of any given deep sky study. So once again, like Messier 28 globular cluster, Messier 8, the Lagoon Nebula can show something decent of its nebulosity even through a 4-inch refractor. Here we have Messier 20, another nebula in Sagittarius. It's fainter, magnitude 6.3, 28 arc minutes in size, 5,200 light years distant, also very low, 23 degrees, negative. Now I'm not sure if we're seeing much in the way of any nebulosity on the screen. I wouldn't expect to either, because the minimum aperture to show a reasonable amount of nebulosity, just like with Messier 8 for a 4-inch scope, is Messier 20 requires a 8-inch scope. Meanwhile, the values that are calculated for are based on being in the middle third of the sky, which is certainly not the case. Even though this nebula, which I think I'm seeing some visibility in here, is just a little past culmination at this point. So not bad. Through the 6-inch settings, we are seeing some of the nebulosity associated with Messier 20. Now here we have Messier 16. It's a nebula in Serpens, magnitude 6, 30 by 40, 7,000 light years distant, minus 14 degrees, but I'm not seeing any nebulosity here. Even though it's the calculation based on its size and its magnitude reveals that a 4-inch scope should reveal something of its nebulosity. However, this nebula is also associated with an open cluster, so it's possible what they've done is they've folded in the brightness of the stars into the total magnitude, which would kind of cause the average surface brightness to be lower than it actually is. So here we are at Messier 16. Let's move on to Messier 17. Well, I may have misreported. Messier 17 needed a 5.5-inch scope. This is Messier 16. Every amateur astronomer has seen this at the eyepiece. It's a very bright cluster called the Swan. It gives a fine view even through a 4-inch scope. I've seen it at 6 inches in aperture. It looks very swan-like. However, this is showing a bit more texture than I might expect. And that's one thing I'm learning about real-time imaging. It does seem to bring out more texture than the eye would recognize in terms of capturing variations in photons. And I have to puzzle through that for characterization purposes. But look here, we're seeing color, and I've only seen it looking like a billowing faint cloud at the eyepiece. So there are definite advantages, even at these 6-inch settings, even though we're still limited to about magnitude 13.5 as your faintest stars, there are still serious advantages to using an imager at settings that approximate to that of a 6-inch or 150 millimeter scope. What we're looking at now is Messier 11, the Wild Duck Cluster. A great view in a 6-inch scope. 4-inch scope should give also a very decent view of this very, very rich star open cluster. And so I think the view we're getting here is comparable to the ones I've seen at the eyepiece. The globular cluster itself has got several thousand stars in it. I could give you some data on it, but I've already sort of done that. What I want to do tonight is basically just give the views that you might see if you were to plunk down maybe $500 on a 6-inch Newtonian reflector, or maybe $1,000 on an SCT or a Maxitov-Cassegrain. I used to use a Maxitov-Cassegrain scope, or the $3,000 you'd have to spend on a high-end 6-inch with a good color correction, and maybe half that if you were to get a 6-inch purely achromatic refractor. And all of these would include the mount, relatively inexpensive mount, probably without Go-To, which I have graduated to after doing years of just pushing to on an equatorial mount in the past. So I'm very appreciative of this mount, and I do have a lot of things to cover, and I would never be able to pull up 15 deep sky studies in a single evening like I can do now within a half an hour of observing time. So I'm going to push the button right now so you can see how long it takes to formulate an image on the screen using these settings. Wow, no image. Okay, I have something very interesting to show you. I could not see the dumbbell nebula M27 at the 6-inch settings. I'm puzzling through it. I realized that the problem may be that 75x is too much. It's a large nebula and its light gets smeared out with too much magnification. So what I'm using right here is 12-inch settings, 64 flood. Now watch as I drop back. So here is what I would consider to be the 9-inch settings. Now notice it's starting to disappear. I could not see the dumbbell on the screen. So here we go. 9-inch settings, we're kind of seeing the dumbbell. So what this illustrates is you need low magnification on anything that's nebulous and large, and I'll have to calculate the average surface brightness tomorrow. And for that purpose, I better go ahead and read the data in so I don't have to look it up. So Messier 27, okay, is 8 by 5.6. If you multiply those together, you get roughly 48, 45. It means you have to add 45. You take the log 2.5 of 45. It's probably somewhere around 5, which means its average surface brightness is around 12.5. Now I'll have to verify that in the morning. But this is the 8-inch view. Let me go back one more click and see if we can still make it out. Well, wrong direction. Wrong direction. Okay, so this is the 6-inch view, and I am seeing it on the screen. I was not seeing it earlier. All right, it was very difficult to make out initially. In fact, I thought the scope might not have properly aligned on it. But there we have it at 75x view of the scope. So let me go back and review this one more time without having the data on the screen, but it was very illustrative of one of the issues you have if you over magnify a faint nebular study. Once again, here's Messier 27, the dumbbell nebula, probably over magnified. I can barely make out nebulosity. Messier 27 is a planetary nebula in Vulpecula, magnitude 7.3, 8 by 5.6 arc minutes, 1,300 light years distant, plus almost 23 degrees. Now, Messier 27 ordinarily would require nothing more than a 3-inch scope to reveal. However, we're not quite seeing that tonight. This is twice the aperture. But on a 3-inch scope, I'd recommend something like 20x. And on this, 40x. Right now we're operating at 75x, so we're kind of diluting the luminosity out on the screen. Something to note. Okay, like Messier 56, Messier 71, wow, Messier 71 should be accessible through a 3-inch telescope, which means its brightest stars should be roughly magnitude 12. So you should see a faint haze with 12th magnitude stars. We're seeing stars probably down to 13.5 with these 6-inch settings. The cluster itself, the globular, is in the sky's middle third, so we are getting a pretty decent view. I'm not sure if there's high thin clouds up there, but remember when we started off, we were looking at Ring Nebula M57, and we could make out that 13.1 magnitude star. Now, ordinarily, you'd see as I've mentioned in other globular clusters, faint hazy glow peppered with a few brighter stars, usually around the perimeter of that glow. So we're not kind of seeing that, though, here tonight with the imaging system. We're seeing stars, but we're not seeing the globular's nucleus of haze. Okay, now this is a very intriguing study. These 5 stars here you've probably seen numerous times in various videos on Golden Phoenix Publish. Typically those 5 stars are associated with a faint nebulosity that swings around like a C, like this. Now if you look next to this star right here, you'll see a little bit of haze. Now, there may be other little hazy regions too. I think there might be a little bit there too. That is all I've ever seen of the Crescent Nebula with a 6-inch scope. Just little pockets of faint nebulosity. So this is pretty much what I expect out of a study that ordinarily you'd need a 12-inch scope to be able to get a minimal view of. So have a good look at that. I'm going to have to probably flip the scope. Now my scope is now pointing to the west. I've been doing that all evening. I'm going to have to do an equatorial flip in order to capture a few more studies I thought might be of interest. One's an open cluster and another is a galaxy that gave a great view, but I suspect we're going to have a difficult time even making out. So and probably we'll throw up possibly Messier 33 and 110, and maybe the nucleus of M31 if it isn't too early in the evening. But those will be add-ons. So that's our view or not view of the Crescent Nebula, NGC 6888. Messier 29 is an open cluster in Cygnus, magnitude 6.6, 7 arc minutes in size, 4,000 light years away, plus 38.5 degrees in declination. Perfect location in the sky. And yet, strangely enough, I am not able to determine whether it's really visible on the screen as an open cluster. All I can note is that there are, when you're only seeing stars down to about 13.5, there's not as many in the field as you might expect. But 7 arc minutes should basically be in this region right about here. So I am not seeing much of a cluster there. Conceivably, one might interpret that as a cluster, but that doesn't quite work for me. And Messier 29 should probably be viewed, a 4-inch scope should make a definite sense of a cluster about it. So I'm a little perplexed by the fact that we're not seeing much in the way of an actual cluster. And I did verify I'm synchronized with Enif in Pegasus, so there shouldn't be an issue with the go-to accuracy of a Losmandy mount. Let's watch this one form on the screen, if it does at all. If you've been following this series, you'll know this galaxy gave a fabulous view the other night, and I think we were operating at about the 16 to 18 inch settings. Probably 128/42. I know I may have imaged it also at 256/44.8. But those are large apertures. Most amateurs don't have 20-inch scopes, although you see them more and more frequently these days, especially if you go to local star parties. The galaxy you're seeing now is NGC 7331, the galaxy in Pegasus. Now, anything under magnitude 10 should give a good view. This one's 9.5, 10.2 by 4.2 arc minutes, so it's a kind of a sub-oblate super edge-on galaxy. Spiral with a bar, 46 million light years distant, plus 35.5 degrees, but it's not near culminating, but it is in the sky's middle third. An 8-inch scope should give a decent view of the core of this galaxy, plus faint extensions going off to each side. We saw a much brighter core and longer, more contrasty extensions when we were using the 16 to 20 inch range of settings on the Rev 2 imager. So that completes my list for this evening for 6-inch views, but how about if we do take a look at if we can get it in the field. If I can, I can't. We'll Carpe Noctem out on this if I can't, but let's go see if we can turn out Messier 110. Okay, due to low sky position, I was not able to really get a good view of either 110 or Messier 32. Here's the core of Messier 31, the great Andromeda galaxy, our neighbor in space. I use it as the fundamental holotype for evaluating all other galaxies. What I basically do with Messier 31 is I know it's about 190 arc minutes across. I know it's roughly magnitude 3.5. I know it's 2.5 million light years distant. I know it's 152,000 light years across. So I can basically use it as a standard candle for evaluating other galaxies by taking Messier 31, moving it as far away as another galaxy, and then either expanding or contracting it so like it's either an oversized or miniature version of itself. Then I can compare its magnitude as it would appear to the galaxy that I'm using to evaluate, using Messier 31 as a holotype, to determine whether that galaxy is packed with more stars or less stars and more cold dark matter than 31. And what I've learned over time is that larger galaxies are less, unless they're ellipticals, larger spirals are less mature, they have a lot more star-forming material left in them. But here's our view of the core of Messier 31 through a 6-inch scope. Now, the best views of Messier 31 are, by the way, are through a 3-inch scope using very low power so you can frame the entire field of view if possible to get a good view. But we're going to make this our Carpe Noctem moment for tonight because the sky position is too far off for 110 or for 32. So we're just going to have this last view of this wonderful neighboring galaxy in space, 2.5 million light years away and getting closer and closer and closer and closer and closer. Carpe Noctem.